Hello students, today I'm going to discuss about a topic related to class 11 with class 11 associated angles. Associated angles, some problems were given in the previous video. Okay, today I'm going to discuss about some difficult or some other type of problems. Okay, just watch the full video. I'm going to That's our problem number one actually. So sine pi by 2 plus phi, we all know that sine pi by 2 plus phi is cos phi, cos phi, right? We all know that this one is cos phi, okay? Cos phi into cos of pi minus phi, that's going to be minus of cos phi, and cot 3 pi by 2 plus phi will be tan phi minus of tan phi. Okay, divide by sine pi by 2 minus pi, that's going to be cos phi. Cos pi plus pi will be minus of cos pi, and cot pi by 2 plus pi will be minus of tan phi. So the total result will be cos pi after cancelling those part. Cos pi cancels, tan phi cancels, and the result will be plus 1 divided by plus 1. So total result will be 1. So that's our problem. Okay. After that, the next problem is sine 3 pi by 2 minus theta, 3 pi by 2 minus theta into cos pi by 2 plus theta, cos pi by 2 plus theta divided by tan pi by 2 plus theta. Minus sine 3 pi by 2 minus theta divided by sec pi plus theta. And what's going to be the result here? Sine 3 pi by 2 minus theta, that's going to be minus of cos theta. Cos pi by 2 plus theta, that's going to be minus of sine theta. We all know the reason behind of it. Tan pi by 2 plus theta going to be minus of cot theta, minus sine 3 pi by 2 minus theta, that's going to be minus of cos theta, and sec pi plus theta, that's going to be minus of sec theta. Okay, minus cancels each other, minus cancels each other. So that is our actually minus of cos theta into sine theta. If we break cot theta as cos theta by sine theta, and this one as cos theta into cos theta, because sec theta can be written as 1 by cos theta. So cos theta cancels here. So total result will be minus of sine square theta minus of cos square theta, and that's going to be minus of 1, because after taking minus 1 common, I'm getting here sine square theta plus cos square theta, and that is always 1, so that will be minus of 1. So that's our second problem for today. Next, the third problem is if n is an integer, n is an integer number, then prove that tan n pi by 2 plus minus 1 power n into pi by 4, that's 1. I'm going to prove that one. Okay. So what will be the procedure here? Here you need to consider two cases. First one is if we choose n as an odd integer, that will be 2n plus 1. Okay. If you consider for any values of m, for any integral values of m, n will be an odd integer here. Suppose we are considering m as 0, we are getting n equal to 1. And suppose if you are choosing m equals to 5, you are also getting 5 to the 10, 10 plus 1, 11, and that's also an odd number. If you choose m equal to 100, that will be also 201, and that's also an odd number. So in case of any odd number, odd integer, the total result will be tan within bracket writing 2m plus 1 in place of n into pi by 2 plus minus 1 to the power 2m plus 1 into pi by 4, and that's going to be, since it's the odd multiple of 90 degree, so tan going to change in cot, and this one's going to be minus. Okay, so cot of pi by 4 I'm going to write here, no problem about that. Actually, missed a step here. That will be m pi plus pi by 2, and that's going to be minus pi by 4, right? Then m pi, after multiplying it by pi by 2, I'm getting m pi here, and 1 into pi by 2 as pi by 2, and minus 1 power 2m plus 1 will be minus 1 into pi by 4, that's minus pi by 4. Okay, so since this is the multiple of odd multiple of pi by 2, so I'm getting cot here. Now that's pi by 4 here, so the principal value is pi by 4, so cot pi by 4 will be the result here. Now in which quadrant this angle will lie, we need to decide that. That's our first, second, third and fourth quadrant, and m pi means maybe m is an odd integer, so in that case it may be pi or 3 pi or 5 pi or 7 pi or something like that. If you consider m as an odd number, that is a rotation of pi will be there, rotation of odd rotation of pi will be there. Okay, so in case of that, the angle lying here, now pi by 2 minus pi by 4, that will be pi by 4, we all know that. So after proceeding to an angle of pi by 4, the ultimate angle lies in third quadrant, and in third quadrant tan is always positive, right? So that will be plus cot pi by 4, and the result will be 1 here. Okay, now if you consider m as an even integer, what will be the result here? M going to says m is equal to 2, so the result will be 2 pi. Okay, complete. Now after that a rotation of pi by 4, so that's also going to ending in first quadrant, and in first quadrant you all know that that's going to be all trigonometric ratios going to positive here, so in that case the total result will be plus 1 also here. So that's our first case, and in case of second case I'm considering m as an even integer, that is 2m. For any values of m, that will be an even integer. Now if m is an even n is an even integer, the total expression will be tan 2m into pi by 2 plus minus 1 to the power 2m into pi by 4. Now 2 cancels each other, tan m pi, and that's going to be plus pi by 4, and the same scenario here. Okay, m pi plus pi by 4, the angle may lies on third quadrant or first quadrant depending on the value of m. If m is an even integer, the total angle lying on first quadrant, and if m is an odd integer, the total angle will lie on the third quadrant. So in that case, whatever may be the position of the angle m pi plus pi by 4, the total value will be tan pi by 4, and that's going to be actually plus, because in third quadrant the tan is always positive, and in first quadrant tan is always positive, so total result will be 1. So in any case that will be 1. So that's our problem actually. So that's how we need to prove this one. Okay, so that's our number 3 problem. After that we're going to the fourth problem. Fourth problem is a comma b comma c are the angles of a triangle, ABC. Okay, definitely a comma b comma c going to be the angles of a triangle ABC, we all know that. Okay, now we need to show that tan b plus c plus tan c plus a plus tan a plus b total divide by tan pi minus a, tan pi minus a plus tan pi minus b and tan pi minus c. Tan pi minus c. Now, what's going to be the result here? Tan pi minus a, sorry, that's 2 pi minus b and that's 3 pi minus c. Okay, no problem. No problem about that. I just know one result, that is for any triangle ABC, we all know that a plus b plus c equals to pi. So, b plus c will be pi minus a, right? And c plus a will be tan of pi minus b and a plus b will be tan pi minus c. Now, tan pi minus a here, no problem about that. Tan pi minus a, tan 2 pi minus b, we all know that that is 360 minus b, and in fourth quadrant that's going to be minus of tan b, right? And 3 pi minus c, 3 pi minus c meaning is that's our 2 pi, that's our another pi, that is total rotation will be 3 pi, then minus c, that is the angle is lying in second quadrant, and in case of this one 3 pi minus c, angle is lying in second quadrant, and for that will be minus of tan c. Okay, then tan pi minus a will be minus of tan a, tan pi minus b will be minus of tan b, tan pi minus c will be minus of tan c here, and in denominator part that will be also minus of tan a, minus of tan b, minus of tan c, minus of tan c, and total cancels each other, cancelling each other, and the total result will be 1. So that's our actually fourth problem. So this is the way you need to solve this one. Okay, now I am going to proceed with our fifth problem. Fifth problem is if tan 385 degree equals to p, 385 degree equals to p, then show that tan 565 degree plus 565 degree plus tan 295 degree, tan 295 degree total by tan 425 degree, tan 425 degree minus tan 335 degree, tan 335 degree, that is equal to p square minus 1 by p square plus 1. Now, just look at this one. I am going to write this one as 90 into 6 plus 25, 90 into 6 plus 25 degree. I am going to write this one as tan 90 into 3 plus 25 degree, okay? And in case of this one, I am going to write it as tan 90 into 5 minus 25 degree, and in case of this one I am going to write 90 into 4 minus 25 degree. So that's our basic step. Now look at this one, that's going to be 90 into 6, so no change will be there, tan 25. Here this one's going to change, and that will be cot of 25. Okay, no problem. 90 into 5 means odd multiple, that's going to change here, cot 25. And in case of this one, tan 90 into 4 minus 25, that's going to be tan 25 degree. Now what will be the signs here? Tan 90 into 6 means 90 into 4, then 90 into 2, then a rotation of 25 degree, that is I am ending with third quadrant. In third quadrant tan 25 always positive. Okay, then the next part, 90 into 3 plus 25, 90 into 3 plus 25 definitely lies in fourth quadrant, and in fourth quadrant tan is always negative, so that's going to be minus cot 25. And here tan 90 into 5 minus 25 degree, 90 into 5 minus 25 means 90 into 4, then a 90 also, then minus 25, that's it's going to be ending in first quadrant, and in first quadrant all is positive, so cot 25 will be the result here. And this one, for this one, 90 into 4 minus 25 will lie in fourth quadrant, and in fourth quadrant tan is always positive, negative. So minus minus plus. Now what is the value of tan 25 and cot 25? So for that you need to calculate this one. You need to consider this one 385 as P, and 385 you may write this one as 360 degree plus 25 degree, and that's our P. So 360 plus 25, we all know that that's going to be tan 25, and tan 25 equals to P here. Okay, no problem. So tan 25 is P, plus minus minus makes it minus, and cot 25 is 1 by P, right? After that, cot 25 is 1 by P and tan 25 is just P. So the total result will be P square minus 1 divided by P. Total divided by 1 plus P square divided by P. P cancels each other. So the result will be P square minus 1 divided by P square plus 1. That's our problem. So that's our fifth problem. After that, I'm moving on to the next problem. That's our sixth problem. The sixth problem is I need to find the value up to nth term, that is cos theta plus cos of pi plus theta plus cos of 2 pi plus theta, cos of 2 pi plus theta, then cos of 3 pi plus theta, and so on up to nth term. And you need to find the sum of this series. You need to find the sum of this series. Okay, so the result is cos theta cos pi plus theta. We all know that that's going to be minus of cos theta because it's in third quadrant. Here you are going to find cos theta also, and here you are going to find minus cos theta, and so on and so on. That's the procedure. Now if n is an odd number or an even number, n is an even number, so the required sum will be cos theta minus cos theta plus cos theta minus cos theta plus cos theta minus cos theta, and so on, because I'm moving on up to an even number of terms. So if you are considering even number of terms, so the bracket will end in some time. Okay, no problem. Cos theta minus cos theta minus cos theta. So for any even value of n, there will be a minus cos theta also. For a cos theta, there will be a minus cos theta also, and so the result will be 0 plus 0 plus 0 plus 0 plus 0, so on. That's going to be the result here. Okay, now the total result will be 0. And if n is an odd number, so what's going to be the result there? The result will be, then the required sum will be cos theta minus cos theta, no problem. After that, plus cos theta. Okay, then minus cos theta, again minus cos theta plus cos theta. Okay, no problem. Same way we are moving, we are proceeding up to the nth term, and here n is an odd number. Okay, so if you consider n as an odd number, cos theta and minus cos theta will cancel each other, but there will be an extra cos theta. So for that extra cos theta, the total sum will be cos theta. Suppose cos theta cancels here, cos theta and this cos theta cancels here, minus minus plus cos theta minus plus minus cos theta. These two cos thetas are gonna cancel each other, but there will be one extra cos theta. One extra cos theta will be there, and so that's why the total result, the total sum will be the cos theta. So that's our problem number 6 actually. So when n is an even number, the required sum will be 0, and if n is an odd number, the required sum will be cos theta. So that's our another problem. After that, I'm moving on to the seventh problem. Seventh problem is something like for a quadrilateral ABCD, for ABCD quadrilateral, cos A plus B plus C minus cos a plus b plus c plus 2d. Cos a plus b plus c plus 2d. That's going to be 0. You need to prove this one. Okay. So we all know that for a quadrilateral ABCD, a plus b plus c plus d is always 0. We all know that thing. So if this one equals to 360, so that will be cos of 360 minus of d, right? And that part going to be a plus b plus c plus d plus d, right? So if a plus b plus c plus d is 360 degree, so what will be the position here? The result will be cos of 360 minus d minus cos of 360 plus d. Now, cos of 360 minus d will be, we all know that that's going to be cos d because it's in fourth quadrant, and in fourth quadrant cos is always basically positive. So, according to the rule, all sine tan cos, add sugar to coffee. That's the rule actually. So, cos 360 minus d will be cos d. Okay. Now, what will be the result in case of cos of 360 plus d? Cos of 360 plus d, it's also ending in first quadrant. 360 plus d is a full, 360 is a full rotation, and then anti-clockwise direction rotation of d. Okay, no problem. So it's ending in first quadrant, and in first quadrant cos is always positive here. So 360 degree plus d going to be cos d also. So cos d cancels each other. The total result will be 0. That's our answer actually. So that's our problem number 7. After that, I'm moving on to the next problem, and that's a solution actually. Solution is problem number 8. Okay, no problem. The solve is cot theta plus tan theta. Cot theta plus tan theta. That's going to be 2 sec theta. 2 sec theta. That's our problem actually. Okay, no problem. So what will be the procedure here? What will be the procedure here? Cot theta, you may write this one as cos theta by sin theta, and tan theta, you may write this one as sin theta by cos theta, and this one may be written as 2 by cos theta. Okay. Then the next step will be cos square theta after LCM. Cos square theta plus sin square theta total by sin theta into cos theta. Sin theta into cos theta. And that's going to be 2 by cos theta. So cos theta basically cancelling each other because cos theta can't be 0 here. If cos theta equals to 0, the total system will be undefined. So that will be, the reason will be cos theta not equal to 0. So in case of this one, cos square theta plus sin square theta, since this one equals to 1, so we're getting actually 1 by sin theta equals to 2, and that's why 2 sin theta equals to 1, 2 sin theta equals to 1. If 2 sin theta equals to 1, the result will be sin theta equals to 1 by 2. Now, you need to consider about the fact that in which quadrant sin theta is always positive. And we all know that in first quadrant, it is all, and in second quadrant, it is sine. So, first quadrant and in second quadrant, sine going to be positive here. So, what is the value of half? The half is indicated by sine 30 degree, and for a second quadrant angle, that will be sine 180 degree minus 30 degree. So the result will be theta equals to 30 degree, or it may be 180 minus 30, that is 150 degree. So for theta equal to 30 degree, sine theta will be half also, and for sine 150 degree, that will be also half. So our required solution is theta equals to 30 degree, only 30 degree and 150 degree. And the condition was given something like this one: 0 degree less than equal to theta less than equals to 360 degree. That was the given condition. So as per that condition, our specific solution will be 30 degree and 150 degree. So that's our 8th problem. Then the next problem, 9th problem. 9th problem is root 3 sine theta. Root 3 sine theta plus cos theta, that's going to be 1. Root 3 sine theta plus cos theta, that's going to be 1. Now, I'm just considering here root 3 sine theta. Root 3 sine theta equals to 1 minus cos theta. If you square this one, squaring both sides, we will get 3 sine square theta, 3 sine square theta, and that's going to be 1 minus 2 cos theta plus cos square theta. Now, if you substitute sine square theta as 1 minus cos square theta, what will be the result here? That will be 1 minus 2 cos theta plus cos square theta, and so the result will be 3 minus 3 cos square theta, 3 minus 3 cos square theta minus 1 plus 2 cos theta minus cos square theta, total equals to 0. Now, the total result is minus 4 cos square theta plus 2 cos theta and then plus 2, total equals to 0. If you take minus 2 common, the result will be 2 cos square theta, 2 cos square theta minus of cos theta minus of 1, that's going to be 0. And in case of that, you may